memory matters a lot when you're building agentic applications, and this is particularly important when you're building things that have your own personal data. A lot of people are using OpenClaw for managing their lives, to act as their secretary, to respond to emails and messages. But if it doesn't have the right context, if it's not giving accurate answers, if you can't explain why you're getting different results from the model, then it can't do the things which you need to do with full autonomy. And this is also the case when you're building enterprise systems, when you're doing things in finance, in supply chain, in different industries. You can't build authentic enterprise AI systems unless you understand what's happening at the memory layer and you can optimize and tune it. Graphs are a great way of doing it. They give you a knowledge graph layer, which is transparent. It's how you would describe things. It's composed of nodes, of relationships, very high performance for multi-hop queries, and it allows you to stack different layers of memory where you can have all of your short-term memory, all of your long-term memory, and then all of the reasoning traces from your application fed back into your agentic architecture to give higher quality responses, whether it's your own personal assistant in OpenClaw or they're building an enterprise agent system. And here today, we have the experts in graph and AI memory to talk about how all this works.
Steve introduced 3 kinds of memory to you. He mentioned short-term memory, long-term memory, and then this idea of reasoning memory. So what are those exactly? And you can imagine just in everyday life, when we talk about remembering things, we have some notion of short-term memory. And in an agentic space, it's the same idea, of course. Short-term memory is the memory of like just what you're talking about right now, your current context, and what you just talked about or what somebody else just talked about, your immediate environment. In an agent, that of course is all captured in just the conversational history. So things that you've said to the agent, things the agent has responded back to you, all that is really your short-term memory. And the idea with long-term memory inside of a graph is that you take the short-term memory and you look through it and you say, well, what was really being discussed? What are the people, places, and things inside of that short-term thread within a single session? Pull those out of the thread into a separate space where now they exist as entities that are connected to each other. So you know who was involved, what they were doing, what the topics were, all that separate from the particular session. And now it can be shared across sessions. So it's a bit of shared memory that is now long-term memory. So long-term memory both in time, but also across different sessions. So whether it's a single agent, multiple agents, their small localized memory becomes long-term memory so that they can all learn from each other and build over what they're doing. Now, along the way, the agent hasn't been just having a conversation with you, which is in the conversational history. It's also been doing tasks. You typically ask it to do something for you, whether it's answer emails, schedule some meetings, or other coding tasks, perhaps. So those coding tasks, all the other things you're asking it to do, are subject to not just what to do and who's involved, but also how to do it. What tools are involved in doing that? What's the context within which those tools are operating? And we all have this idea of like reasoning traces, which is we see like, the thoughts spoken out loud from the agent sometimes. We're like, hey, I'm going to try something out. Did that work? Now let me back off, try something else. Those get preserved in memory as well. And it's those memories that are actually even more important than the what, the who is involved, the what's involved, what you were trying to do. How you went about doing it is how self-learning ends up happening. So that an agent over time, the more it does any kind of activities as an individual agent, multiple versions of itself, lots of different agents working in the same area together, what they're working on and then how they work on it is how self-learning ends up happening. That's the most crucial part of memory, both for us as humans and also the same for agents as well.
We're a big fan of Lenny's podcast. So let's spend a little bit of time looking at how we can use Neo4j as an agentic memory store for an agent that allows us to interrogate and learn about all the things that Lenny teaches us about. All of the episodes from Lenny's podcast were processed with short and long-term memory created from the conversations in the podcast. Asking the agent a question such as, what has been said about the future of AI, will result in the agent using its tools to retrieve data from its memory stored in Neo4j. We can see Lenny's podcast discussions about the future of AI have been conducted, notably featuring guests. Now, the agent has access to all of the conversations stored in memory, so we can explore other related conversations, such as, what else did Kiriti say? And it's going to use its memory to explore what Kiriti said about other topics. Now, this ongoing conversation is also stored in memory, allowing me to reference previous messages, such as what people or organizations is he connected with, he being Kiriti. Again, it's going to use our memory to search and find organizations who Kiriti is related to. And the context shows that this question is being answered by relationships in the graph. We can see that Kiriti has relationships to all of these other people and organizations. The graph in Neo4j shows how the three types of memory are stored. The short-term memory is stored as a chain of messages which form a conversation, starting with a session, moving on to messages in a chain that represent the conversation that we just had with the agent. Now, the long-term memory is stored as a knowledge graph of entities and relationships. If we find the entity that represents Kiriti and expand the relationship, we can see the message where Kiriti is mentioned and also the other relationships to other entities from that conversation. Now, the reasoning memory gives an auditable and traceable history showing what tools we used, the results, and the sequence of them. Try exploring the Lenny's Memory app. Ask questions about subjects you are interested in. Find some connections and an episode that you want to listen to. If you want to learn how to do this yourself, sign up for the Graph Academy Agentic Memory in Neo4j online course.
Thanks, Martin, for showing us how you can use the Neo4j agent memory package in practice, and for all the great use cases where we can apply this, for ABK explaining all the different layers of memory and how they actually apply for the applications we're building. And I think now you can see how this is a crucial part of agentic architectures and why graphs are so important for any agentic application which you want to build. If you want to learn more about this, we have an open source GitHub project where our Neo4j agent memory package is released. We're encouraging people to try it, to give feedback, and to build applications on top of it, which give you more accurate, more explainable, and better quality results from your agentic architecture. So thank you for watching.